And a good afternoon, everyone. Welcome to Issues and Attitudes. My name is Jeff Owens, Director at WEIU. My co-host is Corbin Cox. Welcome, Corbin.
Hello.
Corbin, hello. There you go. Our guests today are going to talk about the eclipse. They're from the EIU Physics Department. The chair, Dr. Steve Daniels, is here. Welcome back, Steve.
Hello, thank you.
Second time on the show. And the first time on the show today is Dr. Robert Strausbaugh, Assistant Professor of Physics and the Observatory Director. Welcome.
Yeah, hi. Thanks for having us.
Appreciate you all coming in today on this Monday. We're 1 week away from the eclipse, so I guess let's just fast forward a week. In a week from today, what can people expect here in the Eastern Illinois area?
Well, we've got three different sites that we're going to be doing things at. We have Robinson High School has partnered with us to allow us to use one of their athletic facilities, and Robert is going to be taking a bus down there, a van down there, because that will be in the totality area. Whereas in Charleston here, we're going to be at the EIU Observatory. We're going to be showing, we're going to have the College of Liberal Arts and Sciences tent will be out there. We have some giveaways. It'll be a fun time. And we're going to be at almost 100%, not quite. But there'll be plenty of activities for viewing. It should be a good thing to see. And the third place is Lincoln Sargent Farm. We've partnered with the Charleston Tourism Board a little bit, and we're going to do a little bit out there too. So that's even a little bit closer, but still not quite in totality. But the totality will be really the best place to be to get it.
Robert, you are kind of the guru here for the science of this thing. So people who just don't know or haven't paid attention, who are just kind of figuring out the next Monday's a special event, what is the science of the eclipse and what can we expect?
Right. So the science for eclipses in general is just so I guess to back it up a bit, all of the light that we get from things in the solar system come from the sun. So even when you look at the moon at night, you're seeing sunlight reflected off of the moon. So basically all the light that we see is coming from the sun. So eclipses happen when something is blocking light from the sun. So on Monday, we're going to have a solar eclipse, which is an orientation where you have the sun out in space, the moon passes in between the Earth and the sun, blocking the sun's light.
There you go.
And is that what the totality is that he was referring to?
Right. So the totality is when a small region on Earth where when you look at the sun, the moon will be completely blocking all of the disk of the sun. But in Charleston, the alignment won't quite be right. So the moon will be covering 99.9% of the sun's disk.
I think we have some pictures of some ideas that if you're going to watch on your 13 or WEIU later, that you can see those pictures and see some of the examples that you guys sent. There's obviously some rules about looking into the eclipse and stuff, so let's go through some of the safety so people just don't walk outside their offices at 2 o'clock next week and look directly into it, mostly if you're in some of the areas where there is totality. So what should people be doing?
So the sun is actually dangerous no matter how little of it that you could see. So even if you're at 99%, you shouldn't be looking at the sun with your naked eye, because your eye is designed to focus that light down, and it'll focus it enough to hurt the cells in the back of your eye. So you don't want to be looking at that no matter what. Only in totality would you ever want to look in that direction without any protection on. But we do have some special glasses that you can use that will block out it blocks out almost all the light, actually. It turns out it blocks out, only lets through 1/1,000,000th of the light. But with 1/1,000,000th, you'll actually be able to look directly at the sun then through those glasses. So you should always have something like that. Sunglasses aren't good enough. Typically, whatever you might just have around isn't going to be good enough. You want the real glasses, solar eclipse glasses that we have a few of, and we'll be giving those out actually at all three of those locations.
Awesome. Corbin?
What makes this eclipse so special compared to other ones? How often does something like this happen?
So I think Dr. Daniels might have the statistic. Is it every place on Earth will have an eclipse every 300-something years?
About 375 years or so, on average. any given location in Earth will get an eclipse. We've been fortunate enough to have 2 come by in 8 years. It's really kind of amazing. They do come by, they do happen, about every 2 years or so, somewhere on Earth? Or?
Oh, there are 2 eclipse seasons every year on Earth, and that comes back to the orientations for how the eclipse will happen. So if we want to get more into the science, we can talk about that too.
No, you go ahead.
Go ahead,
I think it's
So-
fun to learn new stuff, right?
So we talked about the orientation that you need is the moon to be in between the Earth and the sun.
Yeah.
That actually happens every month. So if we think about the phases of the moon, when you go from new moon to half moon, crescents, and all that, that's just due to where the moon is in its orbit around the Earth. So new moon, where there's no light reflecting off of the moon and coming towards the Earth, happens because the back part of the moon is being illuminated by the sun, and we're just seeing the part of the moon that isn't facing the sun. So that does happen every month. So you might expect to get an eclipse every month, but that doesn't happen. And the reason that doesn't happen is there is a plane that the Earth goes around the sun, and its big circular, almost circular orbit. And the moon's orbit around the Earth is slightly offset from that plane of orbit. I think it's like a 3-degree tilt. And so the orientation that you need for the eclipse to happen, the moon has to be in the right part of its orbit that's 3 degrees offset, and that only happens twice every year. So it'll have, if this is the plane and this is the plane of the Earth, Sun, and this is the plane of the moon, that'll just happen once here, and then it comes back around, and then it'll happen once again in its circular orbit.
So the one that we're going to experience on, on April 8th, it's a pretty big deal then, right? Because it's that's why people are so excited in the science world, but everywhere. I mean, there's people. It seems people are really excited. And Dr. Daniels, you were telling us before that this eclipse also is one of the few ever that's going to hit Canada, Mexico, and the United States. How often does that happen?
That's only going to happen once this whole millennium. This whole century.
Oh, really?
Only once this century. It doesn't happen very often to have that particular path. The last path came sort of across the U.S. and only hit the U.S. It doesn't happen all that often even to hit the U.S. The probability that it'll happen twice a year, yes, but a lot of the world is water, right? So it doesn't come across where we are very often at all.
So the one that's going to hit this year or this week, this Monday, only happens once a millennium. I guess the question for the layperson is, how do we know? How do you know that? Can you take us through that part of the science? Is it mathematics? Is it just knowledge? Or
well, you can imagine that the orbits of the Earth and the Moon are pretty regular, right? They don't change very much at all. So once you have that pattern down, it's easy enough to figure it out. It turns out that there's 18 years and
I think it was like a 17-year cycle.
17-year cycle, something about 17, 18-year cycle, where it sort of gets back into the same location more or less, but it misses by, actually, it turns out, a third of a day. So it turns out if you really want to wait here for the next one, you have to wait that 18 years and then 3 times because it's a third of a day. So then it gets in this general area only, about every 54 years or so.
There you go.
But there's actually, like he said, there's a couple of different directions. It can be coming up, it can be going down. As the moon is doing its orbit, it can either be going up or down. And what time of the year is another thing as to where things will be, because as the Earth moves, that plane doesn't change for the moon. So you could be correct at other times of the year. So you get actually a variety of these potential eclipses. And then this one happens to be one that did pretty well for us. And whether or not it's an eclipse that is, it showed a minute ago something about the umbra and the penumbra and all that. it depends a little bit on exactly how far away the moon is from the Earth. And when it does its orbit, it goes a little closer and a little further, just a little, not
Yeah.
very much, but
But that
just,
can factor a lot, right?
just enough. You can have total eclipses, and then you can have annular eclipses. If the moon is actually closer to the Earth at one point, it doesn't completely cover the sun. Even if you're in the perfect place, it won't cover the sun, and you see this circle of the sun around it. Those are actually fairly impressive. We had one of those in about 1994, I think it was. So they do happen. These eclipses do happen, but being total is another issue. And so we are lucky this time around to have one so close, especially
Yeah.
only 8 years after it came by, or 7 years after it came by in 2017.
Cool.
So I guess my question is, obviously this is, as you said, like a once in a century type of thing. People should want to go out, but maybe if there's someone out there who's listening who's like, I'm just not that interested in going to see it. Is there like something you could tell me like, this is why I think you should go. This is why I think it's important.
That's a good question.
Yeah, that's an excellent question. From what I understand, I've never actually personally been in totality. I've been at a couple of close bys, but
Yeah.
never really been in totality. But the people that go to totality talk about the experience is amazing because as the moon covers the sun, the temperature drops. You feel that. All the birds and bugs all want to go into nighttime mode, and so they go quiet. And of course, all the people that are there go, ooh, ah. And so it's really quite an experience to actually feel all that personally, rather than sort of see it on video. On video, you don't capture it, right? You can't.
How long will it last in totality? Maybe down in Robinson where you'll be, Robert?
Yeah, so Robinson will be in the kind of 3 to 4 minute range. The maximum amount of time for totality for this eclipse is a little more than 4 minutes. And as you get, there's this, when you talked about the umbra and penumbra, the size of the umbra, the closer you are to the center of it, that will dictate how long your total eclipse will last.
The umbra is the full shadow.
Okay. And then, like, when you say the temperature drops, I mean, how is it, like, noticeable, like 10, 12 degrees? Or, I mean,
It would be like being completely in the shade on a sunny day versus being out in the sun.
that's cool. I had a brain lock there. At the observatory, I mean, are you going to, do they, what, I've never been there, so are they looking through some type of telescope, or how does that work when they're doing the observatory thing here on campus?
We plan to set up some telescopes. We actually have a solar telescope. I'm not sure whether it'll be up and running at that point, but we do have some other telescopes that will be able to image it. You won't be able to look through it, but
Yeah.
you can see the image of the sun through that, and we did that also in 2017. It's a good way to see it. Turns out there's lots of ways to see it, though. You've probably heard of pinhole cameras.
Yep.
Turns out that if you can just put almost any kind of hole, a distance, relatively small hole, some distance away, you can actually see a pretty good image of the sun through that. And so we're going to have something we just sort of designed, made, whatever. Dr. Burns, Diane Burns, had this brilliant idea of something she calls a gazebo pinhole camera, where
Yeah.
you put a pinhole up on top of one of these extendable gazebos,
Yeah.
and you can see down on the ground. The image gets to be maybe 2 or 3 inches across of the sun. And once the sun actually starts getting blocked by the moon, that view will go from a circle to a crescent all the way and then come back. So we'll be able to see that. That's another method for looking at it. Of course, we'll have the glasses to look straight at it. But yeah, we have some good ways to do it.
And we'll have a couple of ways to directly look at the sun because we got binoculars with special filters on the top of them to block the light coming in. So
Okay.
those will be good for if you want to look directly at the sun.
I have not checked the weather for a week from now. Has anybody done the pre-look to see what it looks like it's going to be Monday?
Partially cloudy, so that's better.
That means partially sunny, though, too.
Yeah. So when I checked like a really extended forecast, it said rain, but they've knocked it down to just cloudy. So hopefully that will continue to improve.
And just last Tuesday, the library had a speaker that made the claim that because of the moon covering the sun, changing the temperature, all that tends to change the clouds, so that even if it's cloudy, it might clear up just for
Oh,
the
really?
eclipse. Yeah,
Didn't know
based
that.
on the way the the moon and the sun change the weather.
That's interesting stuff.
Yeah, that is interesting. I didn't know that.
Not a human being goes anywhere without their cell phone. Should they take cell phone video of the eclipse if they can, or can that hurt the phone? Do you know?
I doubt you get very much.
Okay.
Yeah,
Because it is too bright for
It
that.
wouldn't hurt the phone. I think the advice that I would give is to take video of the ambiance of the event
Okay.
rather than
Just
trying to look at the sun with your phone pointed up in the air.
There you
Yeah.
go.
Take your video off, take your pictures off of the web when it's over,
Yeah.
and take pictures of the people around you while you're doing it.
That's kind of cool.
What are some side effects if you don't take the proper care with how you're supposed to look at the sun? I know you talked about like burning the cells in your eyes, but what exactly can that do? Like probably blindness as a result, like total blindness, partial. Maybe just scare our listeners a little bit into doing it right.
Where are your glasses?
Certainly, partial blindness is one of the results, because you could burn part of your retina, and it,
This sounds bad.
yeah, you don't want to play with that.
Avi, what do NASA scientists, physics departments, what do you hope to gain in terms of like learning from the Eclipse 2024? Is there stuff out there that you're going to be able to take from this and teach or educate in the future?
So there are a lot of interesting science topics that you can study during an eclipse that you can't study at other times. So one of them being the atmosphere of the sun. So the sun isn't just it is just a ball of gas and plasma, but there's also an atmosphere, kind of like we have an atmosphere on the Earth. The surface of the sun is so bright, it's very difficult to study just the atmosphere of the sun. So during an eclipse, the moon is doing a lot of work for you, blocking all that extra light, and so you have a chance to study directly the atmosphere of the sun. Historically, there have been some very important tests of general relativity that occurred during total solar eclipses as well. So there's a lot of cool science that you can do that is meaningful and impactful, but on kind of maybe more the scale of what we're talking about here, it's just a really great way to get people interested and engaged in physics and astronomy in general.
The other thing that I didn't know until I did some research was that there's a chance, if it's clear enough that day, that you can see 5 planets for the first time, maybe ever, for a lot of the people that are, that are alive today. So talk about that and what they may be able to see,
Yeah, so because
and why, I guess, too.
because the moon is blocking all that light from the sun, the stars and planets are always up in the sky. It's just that the sun is so bright you can't see them. So you block all that light from the sun, now background stars and planets are now visible. For planets that are closer to the sun than the Earth is, like Venus and Mercury, it can be harder to see them at night. They tend to rise or set kind of around dusk and dawn. So to be able to look at them during the middle of the day is not a common occurrence. And because they're only visible dusk and dawn, if you wanted to look at multiple planets in the sky at the same time, that doesn't happen very often, because if the other planets aren't rising until later in the night, then Mercury and Venus have already set by that point.
So we'll see Mars as well, and that going or not?
If we're seeing 5, then it's probably going to be Mercury, Venus, Mars, Jupiter, Saturn.
Okay, all the way up. That's pretty cool. That's what I think would be the cool part of this,
The devil. There's a comet also.
Oh,
that's
really?
Fairly near the sun right now, that we'll be able to see that we normally wouldn't be able to see also, right? It's a comet, right?
Oh, I hadn't heard
okay.
that.
Breaking news right now.
I believe there's one.
You can see, stars,
I'm not an
planets.
astronomer, so I couldn't guarantee it.
Is there anything that we just don't know about eclipses that that can maybe be learned this week or next week, or or do we kind of know everything and now just the fascination of when they come?
Well, the sun is currently in a fairly active state in terms of solar flares and things like that. So there may be some very interesting things that we could see from a plasma physics sort of point of view, watching how charged particles flying off the sun interact with the magnetic fields of the sun and all those kinds of things. So there are going to be a lot of people looking at it for real science.
Okay.
I'm sure.
Now, will you be doing that too, Steve?
I'm not at that level.
You're not at that level? Okay.
I'm just going to try to keep the telescopes working.
Yeah, no, I think for us, this is an outreach activity.
Yeah.
All right, that's cool. I just, that's neat. Courtney, anything else on
For people who are planning on going to the sites that you guys will be at, do you hear like how big the turnout is going to be? Maybe how long they should anticipate? Like how many other people? Like travel times? Anything like that?
It's really hard to predict at this point. We're hoping for 1,000 people at the observatory for us. I mean, that would be great if that many students showed up and people showed up. But you never know. But the one thing we found from 2017 was the roads got messed up because everybody from Chicago wanted to go see it at that time. And so you got one day when people are all going to drive to the areas of a totality, and that's going to really snarl traffic badly. In
I think that Robinson to Dietrich, that whole area down there
Yep.
is going to be, people are, they're having sales and hotel rooms are already booked. So
we heard that Robinson canceled school that day because they figured they couldn't get the buses to go back and forth.
it's pretty cool.
I have some friends who live there. I'll tell them just put lawn chairs out.
You don't think about it until you do some research. You realize this is really a big deal, and I don't know if a lot of people know, because everybody gets wrapped up in it's Easter, it's March Madness, spring's here, spring break, and all of a sudden we're having this kind of once in a lifetime event with the Eclipse 2024. Anything that we forgot that you want to get the word out? We have about 6 minutes left today. We're talking to Robert Strausbaugh and Steve Daniels from the EIU Physics Department about the Eclipse 2024. Guys, anything else we forgot?
Well, I do want to thank some of the other collaborators that we've been working with. The Student Life, EIU Student Life has been very helpful to us. I really appreciate those people. And the art department and the library have both also been very helpful. There's a wonderful display of student art related to the eclipse in the library that I think you should go see too. The library is going to run a live feed of the eclipse from some other location, I think. But they're going to run a live feed during the event too, so it should be another way to see it if you want to.
There you go. Robert, how about you?
Yeah, I would say when we were talking about the eclipse glasses and stuff earlier, if you are in totality, you'll know it's safe to remove your glasses, because when the moon completely covers the sun, you won't be able to see anything anymore through the glasses. So that's your cue to take your glasses off, and it's safe to look and actually see the halo of the sun as it's kind of going around the moon,
And at
seeing
what
the
point should they put
atmosphere.
them back on then?
So that's where you need to either be very quick to put them back on, or maybe set a countdown timer on your phone if you know, okay, I've got 3 minutes.
All right.
I think a split second of, oh, it's getting bright now, I'll close my eyes is probably safe. But I'm going to keep looking because I think maybe I saw something interesting. Maybe I saw a sunspot, and I'll keep
There's
looking.
more.
Don't do that.
It'll be the last thing you see.
And related to that safety, just today at 4 o'clock in the Whittier room of the library, we have a speaker, local
The
eye doctor.
optometrist, yeah. Rob
Local,
was talking about him this morning.
Yep, Derek Hennig. He's going to come and tell us about safety around this thing. So if you have any questions about that, that's the place to be today.
What about people that are, that work via their car? They're going to be out and about. I mean, and they don't have time. They don't want to stop. I mean, is it a good time to be driving in those 3 or 4 minutes, or should they really try to be off the road at 2 o'clock next week? Because if the sun's coming through, and
I think especially if they have glasses, like take the 5 minutes during totality, especially to stop and take it all in.
then what about the 2 o'clock classes on campus here at Eastern? Does anybody speak for those?
Just got to convince them all to let us out.
Or at least for a while, right?
A lot of the professors I've talked to have said they were canceling one way or the other, but I can't guarantee all of them will, that's for sure.
Scientifically, how is this one different than the one that we had a few years ago? So 7 or 8 years ago, it seems like.
Mm-hmm.
I mean,
So part of it, we talked about the different paths that they can take. The previous one came from the north and down to the south. This one's coming from the south and going up to the north. And that goes back to the way that the moon orbits the Earth. So when it's that angled offset orbit, when it's going basically up towards the north in its orbit, that's when the path of the eclipse goes from the south up to the north. And the previous one, the moon was actually going down in its orbit, crossing the ecliptic, which is that plane that the Earth goes around the sun. So that's kind of the main difference, I think, between the two that happened recently.
What do your students ask you in class about the eclipse? I mean, are they interested and are they peppering you with a lot of questions? Are they excited?
I think some people are excited, yeah. So I've had a few people ask to, like, information about the trip that we're taking to Robinson, and can we join, and that kind of stuff. So, and we've tried to accommodate all those people. So,
Steve, what about you? I mean,
I don't actually have any astronomy type students, but so no, my students they're all physics majors. They're not they're not quite the same.
there you go. The one at the observatory and the one here at the Lincoln Sargent Farm, are those open to the public or just students, or how's that work?
They're open to the public, and so please come on down.
There you go. A couple minutes left. Corbin, any last questions?
No, covered everything on my sheet.
You guys did great. Now let's ask you some kind of fun, unrelated, somewhat related, whatever you want to call it. They're not hard, Steve. I know this isn't your favorite part, but hey,
Oh, sure it is.
It's not hard. All right, we'll just go down the row. Favorite planet?
favorite planet? I think I'll go with Mars, just because I'm maybe thinking in the future maybe humans will be on Mars sometime in my lifetime, and that would be a really cool thing to see and a great accomplishment for humanity.
I always like Mars, too. It's got a lot of cool stuff going on, and it's red.
I don't think I've ever thought about this question before in my life. I'm going to go with
fun.
Jupiter because it looks cool.
There you go. What are you looking... Oh, no, we'll go sci-fi movie. Sci-fi movie. Favorite sci-fi movie?
Sci-fi movie, I think I would go with... Oh, come back to me. I'll have to think about it.
I like 2001: A Space Odyssey. That's been one of my favorites for a long time.
Yeah, that's my answer too.
Mine was the
Sorry,
bullshit.
Archie.
No, it's okay. It's okay.
Like sci-fi TV movie.
Starship Troopers is what I was going to say.
What about sci-fi TV show like
Sci-fi TV.
Battlestar, Star Trek? Or...
Star Trek all the way.
I don't know.
Mine would be
Yeah, I don't know if I have a favorite at the moment.
All right, this is a tough question. Maybe would you go to space if offered?
Yes, I actually applied to be an astronaut
really?
a few years ago when they had the open call for Artemis. So I didn't get a position.
Maybe
but-
next time.
Yeah.
I would, but I don't think I could ever qualify.
Yeah, I don't think I would qualify. It sounds fun.
Well, I can't. Science or physics? Is there a I'm going to run out of time. But do you have a hero, real quick, a mentor that you look up to?
A hero for me would probably be Carl Sagan. Just his Cosmos series is kind of what got me into astronomy.
Thanks, guys, for coming in. Eclipse is next Monday. We are WEIU.